Hello, boys and girls. Welcome to Science in Daily Life. I am Sir Zamin.
And I am Miss Riemann.
So, my young scientists, how are you doing today? I can't hear you. How are you doing today? Yes, that's much better. I do hope that you're doing well and you're prepared for a lovely, energetic lesson today.
Now, boys and girls, last class we would have looked at energy and energy conversion. Now, let us talk a little bit about today. We'll be looking at force and energy. Look around you. Is there anything moving? Can you hear, see, or feel anything around you? Yes. This is because something is making this happen. And most probably, there is some power at work.
So, boys and girls, what is power? Power is the ability to make things happen, which is called energy. Our objectives for today are to identify the relationship between force and energy, to identify what is a force, and lastly, to list the types of forces.
Now, what is that relationship between force and energy? If an object or organism does work, simply saying it exerts a force over a distance to move that object, then we're saying the object or organism uses energy. Simply saying, boys and girls, if I move from point A to B, I am using energy. Now, what is a force?
Scientists, a force is a push or a pull. It can also be a twist or a turn.
So, boys and girls, it's a push
or a pull.
Pull. Now, we will talk more about force. Now, there are many different types of forces, and today we will dive right into them. Forces can be separated into two groups, mainly contact forces and action at a distance force. Let us list some of the contact forces we have.
Yes, boys and girls, let us now look at examples of contact forces. First of all, when you hear the word contact, what comes to mind? It means two things touching each other. They are in contact. So some examples of contact forces are frictional force, tension force, normal force, a resistance force, applied force, as well as spring force.
Now, boys and girls, Sir talked about contact forces. I will now talk a little bit about action at a distance force. It is simply telling you what is happening there. It is the action at a distance, simply saying it is not in contact. Now, some examples of these types of forces are 1. Gravitational force, 2. Electrical force, and finally, magnetic force.
Boys and girls, we can also call forces at a distance non-contact forces. Now, let us take a closer look at the types of contact forces. We will start with frictional force. Friction is a force that is created whenever two surfaces move or try to move across each other. For example, you can simply rub your hands together, and that's an example of frictional force. You will feel a little burn, you will feel a little heat being transferred onto your hands. Friction always opposes the motion or attempted motion of one surface across another surface.
Very well. Now, let us take a look at tension force. The tension force is the force that is transmitted through a string, a rope, cable, or wire when it is pulled tight by forces acting on opposite ends. Have Have you ever played the game tug of war or tug o' war? Simply, it's two sets of people or persons at each end and they're pulling. Now, that pulling will cause some amount of tension on the rope or string being used. At some point, the tension will be too much that it bursts.
Next, we'll move on to normal force. The normal force is the support force exerted upon an object that is in contact with another stable object. For example, if a book is resting upon a surface, then the surface is exerting an upward force upon the book in order to support the weight of that book.
Now, boys and girls, let us take a look at an image that will show you what is normal force. Now, moving on, let us talk a little bit about air resistance force. What is air resistance force? It is a special type of frictional force that acts upon an object as it travels through the air. Have you ever seen a parachute in action? I am pretty sure that the Guyana Defense Force will have some parachute activities where these men or the officers will take a jump out of the airplane or the helicopters and they have a parachute. Now, air resistance deal with the parachute and how it moves. Why does it stay in the air and why is it that they take a longer time to drop to the ground? The force of the air resistance is often observed to be opposite the motion of the object. Simply saying the person is falling, but the air resistance is going upwards.
Next, we will move on to applied force. What is applied force? It is a force that is applied to an object by a person or another object. If a person is pushing a desk across the room, then there is an applied force acting upon the object. The applied force is the force exerted on the desk by the person. So I'm sure, boys and girls, we apply force on a daily basis.
Have you ever hit a nail with a hammer? That is simply an applied force. Have you ever pushed a table or assist your parents in moving around the furniture? It is applied force. Now, let us talk a little bit about spring force. Now, let us look at spring force. The spring force is the force exerted by a compressed or stretched spring upon any object which is attached to it. Boys and girls, have you ever break open one of your pens and you notice in that pen there is a little tiny spring? I am sure most of us would have tried to stretch that spring and try to see what happens to it. We would have impacted that spring with some force, and we caused it to stretch. We can also cause it to compress. Simply compressing means to squeeze that spring down.
Now, boys and girls, let us look at the examples of non-contact forces or forces at a distance. We will begin by looking at gravitational force. Now, gravity is a force that attracts all objects or masses to each other. By definition, this is the weight of the object. All objects upon Earth experience a force of gravity that is directed downward towards the center of the Earth. Why? Gravity is what keeps us standing upright. Gravity is what keeps objects stable from falling off.
Now, let us talk a little bit about electrical force. An electrical force is something that exerts a force on another. It is basically the attractive and repulsive interaction between any two charged objects in an electric force. Simply saying, boys and girls, when we're talking about charges, we're saying they are positive and negative charges. Positive charges will repel, two positive charges will repel each other. Two negative charges will repel each other, whereas a positive and a negative will attract each other.
In addition, boys and girls, we have magnetic forces, which is another example of a non-contact force. Magnetic force, attraction or repulsion that arises between electrically charged particles because of their motion. The magnetic force between two moving charges may be described as the effect exerted upon either charge by a magnetic field created by the other.
Have you ever played with magnets before? I'm pretty sure when I was younger, I would have opened the speakers and I noticed there are little round magnets there. And if I put a little nail to that, there's some attraction happening. Now, maybe once in a while that magnet broke and I tried to put it back together. But at some point, it did not fit each other. It meant that it was repulsing each other. So it could not have attracted each other. So we would have been exposed to magnetic force in our environment.
Okay, students, today we would have looked at examples of contact and non-contact forces, and we would have explained each one of them. We would have looked at the relationship between work and energy, where if an object or organism does work, it simply means it exerts a force over a distance to move an object. The object or organism therefore uses energy.
Now, until next time, I am Miss Freeman.
And I am Sir Zamin.
Bye-bye.